Okay, today we're going over the sine function. And what we mean by this is we're going to be plotting. We have an xy graph here, okay, our Cartesian plane. Y and x is going to be measured in degrees. So it's very important that while you guys go through this, if you're using a calculator, make sure it's in degrees, or a lot of this is not going to make sense of what we're doing. We're going to go over a sine wave, okay? And in order to do that, we're going to investigate the sine wave. So what we're going to do is we're going to start with an x value of 0, and we're going to plug it into our function. Well, the function of this is y is equal to sine x. In other words, what we're going to be doing is we're going to be replacing the x here with 0, or whatever variable we have, and solve for our y values. So we'll do the very first one on our calculator here. Okay. Let's check. See, it's in degrees. We're good. So I'm going to push, can't remember if you hit sine first. Sine 0 equals 0. Very simple. It looks like nothing changed, but there we go. So what that is 1 point on our graph. Now, there are many different degrees between 0 and 90, but I've specifically chosen this point for a reason. And then we're going to go over the ones in between. In fact, it's maybe not a bad idea. Let's go to 45, since it does seem to be one of the points on here. We'll figure out what, when x is 45, what our y is. So sine 45. Take our calculator, 45, whoops, wrong button. 45 sine, okay? So sine 45 is 0.707, kind of an odd number, 707. We try to plot that on a graph. It's a little less than 1, maybe somewhere here. Okay, I've purposely given myself a lot of room for 1. The next number we're going to use is 90. Anybody with their calculator can help me out. Anyone know what sine 90 is going to be?
1.
That's okay, good. It's going to be 1. Sine 90 is 1. Okay, so we get the value of 1. So at 90, we're at 1. Now, what I want you guys to start to notice is the pattern that's going to emerge from this. What would 45 degrees past 90 be? Right in between here. Anyone know? 135. Good. So this would be 135. We're going to plug this value in. Put it in our calculator. 135 sine 0.707. We've seen this before, right? Starting to look symmetrical. All right, obviously, what's the next one we're going to try here? 180. Anyone know what that's going to be?
0.
0. 180 sine is 0. Okay? So, if you're looking at this, and I'm going to try to fill in the first part of this as best as we can, we're going to estimate those other points. We're essentially getting something that's curling, it looks like, coming back down. From here, let's estimate. What do you guys think is going to happen next? What type of shape? Do you think we're going to keep going like this, jumping around? Yeah, you like that idea? All right. There's a possibility it comes back down. Possibility it goes in a straight line. Let's figure out after 180. So what would 45 degrees after 180 be? 225. Good for you. You guys can add it in your head. So impressed. Obviously. Good. So we got 225. 225 sine negative 0.707. So, negative 0.707. I want you guys from here, I think we've gathered enough information that we can probably estimate to get a good idea of what this is going to do. From here, we're at negative 0.707. What do you guys think 270 is going to be? That's right. 270 is going to be negative 1. So we're going to be here. What is going to be at 315? Negative 0.707. So this would be 315. 0 sevens. And then finally 360?
0.
That's right. It's 0. So, yesterday we talked about periodic functions. We fill in the rest of this. If you've noticed, this just completed an entire period. It took 360 degrees, which we talked about a circle on a Ferris wheel the other day. That makes sense for what we're doing. 360 degrees to complete an entire period. Well, this is not a function that ends. It continues this pattern for on and on and on. So at 450, we're going to be back to 1. Okay? So this would go up here. And if we were going to the reverse, at negative 90, we're going to be at negative 1. Negative 180 will be 0. Negative 270 will be positive 1. 360, 0 again. And negative 450, negative 1. So if you notice, we continue this wave. No, it's not the most fluid. We continue this wave pattern. So what we found are many different points along this, but all we really need to know this are some major ideas here, okay? Some of the major ideas I want you guys to know are the max and the min, okay? And we're going to highlight the 5 most important parts of the sine wave to remember. Obviously, we need to know 0 and 0. 90 and 1 will be important. 180 and 0 will be important. 270 and negative 1, and 360 and 0 again. These 5 major points will help us draw any sine wave we want, okay? So here's our original one. These are 5 major important points, okay? From there, we can kind of estimate the other points and continue this wave-type pattern. When you draw this, it is not a straight line, as we've already discovered, okay? At 45, we're much higher than halfway. So this is a wave-type pattern. Now, I want you guys to realize, in a sine wave, our peak or the max is at what value?
1.
X equals 1 or y equals 1? Y equals 1. Okay. So that is going to be our max, and our trough or our minimum is known at what? Negative 1. Good. This is for the original one. Y equals 1. So we went over a lot of this yesterday. Here's our peak for our sine waves at 1. And our minimum is negative 1. We talked about the middle. The middle is called the equation of the axis. Okay? So the equation of the axis, I'm going to highlight it. I'll do it in green. Goes right through the middle. We're actually going to use a formula for this. Okay? The formula for the equation of the axis, we're going to be adding our 2 values together and dividing by 2. Okay? So we take these values. We take our max. I'm going to zoom in so it's a little clearer when I write. Max plus minimum divided by 2 gives us our EOA, we'll call it, equation of the axis. Well, in this case, we have 1 plus negative 1 divided by 0. Sorry, not divided by 0, divided by 2. What is 1 plus negative 1? 0 divided by 2 is 0. So the equation of the axis runs right through the middle at x equals 0. Okay, so we're going to draw that line across. The equation of our axis is at 0. That's one of our other major points. So if you notice, the 5 major points we took here, they either cross at the equation of the axis, the max, equation of the axis, the min, and the equation of the axis again. We only really want to remember points along there because the rest we can estimate. Otherwise, it becomes very tedious to get all of the other points of this graph. Okay? And finally, the last thing we want to focus on is our amplitude. Our amplitude is a similar equation. But in this case, we take the max and we subtract the min. So max, subtract min, divided by 2. Okay, we'll do the amplitude in blue. Well, what was our max? 1 subtract, what's our minimum? So we'll say A equals, that's right, negative 1, divided by 2. What does 1 subtract negative 1? What's 2 divided by 2? 1. So our amplitude of this is 1. And by amplitude, what we mean is the distance from the equation of the axis to the highest point, or from the equation of the axis to the lowest point. And if you notice, that is exactly 1 in this case. The amplitude is 1 on both of these cases. Okay? So, today's lesson is really to get you guys used to looking at a sine wave. That's what we normally call it. This is a sine function graph. Okay? It is a continuous pattern with the same peaks, troughs, and equation of the axis, and it's very similar amplitude. The equation of it is y equals sine x. If there's any variations, I want you guys to make tables and plug values in again to see what the differences are.